Okay, this is section 2.4 on symmetry. Some of these I'm going to do from this document camera, and the ones that don't have diagrams, I'll actually do create a separate video that I'll do and upload. Alright, so I'll let you know which ones I'm going to do. Determine whether the graph is symmetric to the x-axis, y-axis, or to the origin. Well, it's pretty easy to see that if I were to fold this along the y-axis here, these points would lie right on top of those, or those right on top of those. So y-axis, alright, symmetry. And nothing else going on. It's not symmetric to the x-axis, because if I flip it, if I fold it here, these points don't show up here. And nothing going on with the origin. So it's D, and that's that. This way it's pretty easy to see that if you fold it along the x-axis, these points here would lie right on top of these, or vice versa, these would fold right on top of those. So we've got x-axis symmetry, and that's the name of that. Letter C. Number 3, well, we don't have x-axis symmetry, because if I fold it along the x-axis, these points don't show up here, and those points don't show up in the second quadrant. No y-axis symmetry, because if I fold it along the y-axis, these points don't show up there, and these don't show up there. But I do have symmetry. All right, and it's not just because symmetry to the origin. It's not just because it goes to the origin, because a circle is symmetric to the origin, and it doesn't go to the origin. So what I'm doing is I'm picking a point here. All right, let's say I pick this point here, 1, 2, and I'm checking to see if there's a point here, -1, -2. Notice I changed both these signs. I got a point right here and right there, and that's telling me when I change the x sign and the y sign, if that point is also on the graph, I've got symmetry to the origin. Number 3, letter D, the origin, and that's that. Nothing else going on. Here it should be fairly simplistic. Alright, if I fold this across the x-axis, these points would lie right on top of these, or these would fold up and lie right on top of those points there. So we've got x-axis symmetry, and that's all there's going on here. Now, with 5, 6, 7, 8, and 9, yeah, you could replace x with negative x and see if you've got the same equation back. That would give you y-axis symmetry. Replace y with negative y and see if you had the same equation back. And then if you wanted to check the origin, you'd have to substitute in place of x, negative x, and in place of y, negative y. All that being said, you know, the old saying, a picture's worth 1,000 words. So what I want to do separately is I want to graph these on the calculator. We're just going to take a look at it, and we'll determine whether we got x-axis, y-axis, or origin symmetry, or maybe we got nothing. So we'll do those separately on another video. Odd or even? Well, it'll be an even function if the function is symmetric to the x-axis. It'll be an odd function if the function is symmetric to the origin. Alright, so here I've got origin symmetry right here again. A way of thinking about this, if I were to take this and rotate this thing 180 degrees, alright, then this point would lie right on top of that, and this one would come down here. Or like I like to do is pick a point here, I don't know, call this 1, 3, and then you'll see that -1, -3 is also on the graph, alright. So this is an indication that you got origin symmetry. Well, if you got origin symmetry, then you've got an odd function. Origin odd, way of remembering it. Number 10, letter A. Here, well, we don't have x-axis symmetry, because if I fold it along the x-axis, that point does not show up there. We don't have y-axis. If I fold it along the y-axis, this point doesn't show up there. But I do have origin symmetry. And once again, if I pick a point, if I were to rotate this graph 180 degrees, it would look just like the original. Or like I like to do, find a point here. Let's say this is, I don't know, 1, 4. And there's a like point there, -1, -4. That indicates origin symmetry. Origin symmetry means it's an odd function. Here I got absolutely nothing going on. No x-axis symmetry, no y-axis symmetry, no origin symmetry. Number 12, I got nada. Nothing going on. If it went through the origin, that'd be a different story, but it doesn't, so nothing going on with that bad boy. Number 13, at first look, you would think if I rotated this 180 degrees, these points would lie right on top of those. But the problem here is that this is an open circle, all right? So if I rotated it, that point should be an open circle, but it's not. It's a closed circle. So number 13, at first it looks like you got something going on, but it's nothing. And it's because of that open circle there. It's kind of tough to see, but it is open. All right, this one is closed. Once again, same thing in determining whether you've got odd or even. We have to find out whether it's symmetric to the x-axis or to the origin. It's just as easy to graph these guys and look at the picture and then determine, because I'd have to do all kind of substitution and do algebra. I would rather do it on a calculator, and within seconds we'll know what we got. Same thing, odd or even. Well, this point matches up with that. If this is let's say a -1, 2, this is a +1, -2, I've got origin symmetry, which means I've got an odd function, number 18. I got that odd function. Origin symmetry implies odd. O for origin, O for odd. And here we've got, well, there's no x-axis symmetry. This point doesn't show up there. There's no y-axis because that point doesn't show up there. But I do have origin symmetry at this point here. Let's say, I don't know, call it maybe 2, 4. There's a similar point here, -2, -4, or a reflection. All right. If xy is on the graph, then -x, -y, which indicates you have origin symmetry. If you have origin symmetry, you've got an odd function. And this is the same as the one we just saw a minute ago. I think I just repeated this. This was nothing. Alright. Where did I just see that one? Number 12 is being repeated. Yeah. Number 12 was repeated. Alright, so there was nothing going on. Alright, that does it for the first part of section 2.4.